Welcome. Today we are going to be talking about materials engineering. So this is the Society of Women Engineers for East Central Iowa. I am Amy Kerr, and together with me I have Kate Hackinson and Chelsea Kalashevsky. So we're just going to jump right in. Ladies, could you tell me a little bit about yourself, introduce yourself, your name, and your current role?
Sure, I'll get us started. I'm Kate Hawkinson, like Amy said. I was a student in material science and engineering at Iowa State University. I did my areas of specialization in metals and ceramics and electronic materials. And I now work at Seagate Technology up in Minneapolis, and I've been there for about 2.5 years.
Chelsea Kalashevsky. I also went to Iowa State for materials engineering. I specialized in polymers, and until recently, I worked at a company called TO Plastics as a quality engineer, and now I work for a company called Lisi Medical, also as a quality engineer.
And I already introduced myself. I'm Amy Kerr. Also went to Iowa State for materials engineering. Was planning to go into the more biomedical area, but turned and pivoted towards protected materials, the ones that you find in your house for electronics. And I am now going back to grad school for macromolecular science and engineering, which is a fancy way to say polymers or plastics. But still in engineering, and plastics, polymers are one version of materials, which we'll get into in a little bit. And so next question, ladies, is can you explain what materials engineering is and give us a little background about the different types of engineering it involves?
Yeah, so materials engineering is pretty much what it says on the tin. We are looking at the materials that we use to make different things and seeing what the most ideal material would be for whatever thing that we're making. So for example, if you look at the glass windows in a bank, not only do those have to insulate to help keep the heat in the winter and the cool in the summer, but they also need to be protective and a stronger type of glass than you might have in just your windows in your house. And that would fall under ceramics, which Kate specialized in. You might also look at what which alloy, which metals are you going to mix together to be the best type of metal to make the frame in a car, or something else that you might make out of metal. What properties do you need to have the strength and the other properties that you might need to make whatever you're making? And then for plastics, there's so many different types of plastics out there. Which plastic you might choose to make a toothbrush. It's going to need to last for a couple months. It's going to need to be non-toxic, so you can stick it in your mouth, or what type of plastic you might use to create a cover that would go on top of something on top of an RV. So it has to stand up to sunlight for a long period of time. It has to be outside for a long period of time, hot and cold swings. What types of properties you're going to need to be able to be in those different environments with whatever object that you're trying to manufacture.
And so what we really do as materials engineers is we learn a lot about physics and chemistry and what gives different materials their properties. So why is metal conductive? Because the electrons can move really easily inside the material. Why is a plastic cup not as good as a glass cup at keeping your drink cold in the summertime? You know, all of those different things are affected by the individual molecules and the bonds inside of your material. And so we learn all of that knowledge, and then we take it and we apply it, like Chelsea was explaining, and all sorts of different applications, from, you know, what do we want to use to make a frying pan out of, to, you know, what's the best material to build your house out of. You know, every single thing that we touch big and small. Someone designed on purpose what material or materials that was going to be made out of. And, it might be, what's going to do the job and be the least expensive, or it might be, what's going to have this very, very specific, unique combination of properties that we care about. And so it's really dependent on what your company is trying to do. What are your main goals? And a lot of times it's a balancing act between, well, we want this to perform as best as we can get it, but we have a very limited budget, or we can't spend a ton of time manufacturing this. And so all of those considerations for how easy we can make it, are we going to make one part, or are we going to make 1 million in the next year? That also plays a really key factor. And now that I'm currently working in a manufacturing environment and process control, that's also something that I think about a lot more than I think I ever used to when I first started looking into this field. So there are really a lot of different aspects to consider, and it's all just part of being in an engineering role as part of a team. And so our kind of main contribution to the team is to be both a specialist and a generalist, because we need to know a little bit about a lot of different types of materials, but also be able to, do research or know other people who are specialists on certain types of materials to go and find what is the best solution for the problem at hand.
Awesome. Do you think you could maybe give us an example of what makes a materials engineer different from other types of engineers? It might be easier with kind of an example. You mentioned like we play a part when products are produced, but what is our part versus other people's parts? How big is that product? Is it a whole house, we're building it? We could.
Sure. So I'll speak first about the internship that I was in when I was in college. I worked in a team of materials engineers for a company that made big giant valves that go inside of manufacturing plants that make all different things from, gasoline for your car to places that make paper. Like we used a lot of different materials in the different products that we sold. Some of them were just plain metal pieces that went into the valves. Others had a plastic coating on them for corrosion resistance. But most of my work was looking at parts that were sent back to us from customers when they broke, and having to do that analysis of, why did this part fail? Was it because we manufactured something that was faulty or that did not meet the required specifications from the customer? Or was it because the customer did something with the valve that we were not anticipating? Was there something in their use of the product that we hadn't considered? Like, was it operating at a temperature that we didn't know about? Were there additional chemicals, such as a cleaner, that was used in their system periodically that was causing the failure that we didn't know about? There are a lot of different things. And so materials engineers really play the role of an investigator, I think, a lot more than other types of engineers. And we have to be really, really detail oriented and attentive to the smallest things. There was a lot of laboratory work, a lot of using microscopes, a lot of running experiments where we would take a sample of the material and put it in acid to see if it would corrode, or put it in a furnace at high temperature and see if it would perform differently because of that. And so there were always new problems to solve, and we were kind of the ones that were expected to do that investigative work, while all the other engineers in our team and in our company were much more focused on designing the initial part. We were the ones who would deal with issues after the part was already sent to customers.
Yeah, and that plays a lot into what I do as a quality engineer as well, is looking at the issues that a part might have after it's been sent to a customer. I think a lot of times when you're looking at how materials engineering is different from other engineering, you're looking at materials versus chemical engineering and materials versus mechanical engineering. Sorry, I forgot the word for a minute there. And I find that the difference between materials and chemical tends to be in materials, we're working a lot more with solids, like we talked about earlier, metals, ceramics, and plastics. And those plastics are sometimes a liquid, but in chemical engineering, they're more often working with liquid chemicals, especially on a very large production scale. Think like producing medications or producing cleaning material, cleaning liquids.
Or like ethanol.
Exactly. So that's kind of the difference between materials and chemical engineering. Materials and mechanical engineering, a lot of times the mechanical engineer will be more designing the process or designing the product, and then they will consult the materials engineer for, okay, if I need XYZ properties, like Kate mentioned earlier, what material do you think would work best to fulfill those properties, while also, again, as Kate mentioned, keeping that cost down. So yeah, the mechanical engineer would be working more on the process and the design, whereas they would bring the materials engineer in as kind of a specialist for choosing that material.
And sometimes,
Kate,
sometimes the mechanical and materials engineer would then work together to design a prototype or a test to check whether their material choices that they were considering were going to perform as they expected. So that's when materials engineers kind of get involved in the design process.
Awesome. So you told us a lot about what you do, but could you kind of give us the general day? How much time do you roughly spend doing different activities? And then if you had to choose one super most exciting thing that you get to do at work, what would that be?
I can start. In my job at Seagate now, I actually do less materials engineering per se, but I still use my materials knowledge a lot. My plant manufactures really, really tiny electronic devices that are mass produced on a wafer. It's about the size of a dinner plate, and each wafer contains about 100,000 devices on it. So they're really, really, really tiny, micron to nanoscale. So that in itself presents a lot of challenges, because that means every single time we want to do any sort of measurement or testing, we have to use either a microscope to take pictures of the wafer and do measurements that way, or sometimes when we do, like, let's say we put a thin film of metal over the top of the whole wafer, then we can do a sheet film measurement before we pattern the metal into the shape of the device that we're making. So a lot of what I do is a little more general than specific materials engineering, because, you know, there are times that I use skills that I learned in my degree, such as how to use a microscope manually and go look at a wafer if I'm worried that something is not as it should be. A lot of it, though, too, is just using that attention to detail and those investigative skills to go and think, okay, is the problem I'm having caused by the current process that just happened on the wafer? Is it related to the measurement tool itself not measuring correctly? Or is there something wrong with this piece of product from several steps back in the process? So I I would say I spend probably 60 to 70% of my day looking at individual wafer issues. I also have to, because it's a manufacturing environment, in order to keep processing wafers, like we have thousands running in our factory at a time. And so a good portion of my time is also spent paying attention to the tools used for manufacturing. So are they running correctly? Is something broken? Does a process need adjustment? You know, there are different settings on the tool that are used to determine, you know, how thick of a layer of material are we going to put on our wafers, things like that. And so I will have to sometimes go in and make adjustments to processes. And I will, you know, consult with the process engineer who owns that process or that tool sometimes if I need help for how to do that. But most of the time, I have instructions for how to do it myself. And so it's a lot of individual work, but consulting coworkers on a pretty regular basis when I want a second opinion or need help with something.
Yeah, it sounds like what I do is actually pretty similar to what you do, Kate. Like I said, I'm a quality engineer, and I'll start with my previous job. I just switched jobs maybe a month and a half ago, but my previous job was very involved in plastics. I worked as a quality engineer at a company that made plastic trays for carrying medical devices. So a lot of what I did was looking at the quality of those trays. I spent some time looking at what material we made the tray out of. Some of the companies had requirements for sterilization. They wanted to be able to put their medical parts into that tray and then run it through some sort of sterilization process, which might include high temperatures. It might include particular chemicals. And whatever plastic we made that tray out of had to be able to stand up to that sterilization process. So I did do some advising on what type of material we would want to make that tray out of. I also looked at some quality issues where we were using recycled material to help produce that tray when we extruded the plastic to make those flat sheets before we formed them into whatever shape the tray is. And sometimes if we had too much recycled plastic, it would reduce the quality of that tray. So I would have to look at, okay, did we get too much recycled material into this process? Can we reduce it while still maintaining some recycled material to be more environmentally friendly? And how can we improve the quality without reducing that recycled content too much? So a day in my life at that office would be maybe about 30% of the time, 30% of the time out on the floor, actually watching the process, watching the product, checking things. I wasn't a quality inspector, but I was out there just observing on occasion just to make sure that if there was something running that I knew had issues recently, I would go out there and just keep an eye on it. Pulling samples from the warehouse to check something that a customer had complained about this product, and I know we have some in inventory, so now I have to go look at it to make sure that it's okay. And then the rest of my time was spent at my desk working on customer correspondence, documenting the issues that we found, doing research into ways that we could fix those issues, collaborating with other team members, talking with process engineers or design engineers on changes that we could make to improve the quality, and working with sales as well, as I mentioned earlier, to look at the materials that the parts were made out of and potential changes that would need to be made there. And my current position is pretty similar. It's pretty much all of that except with metals instead of with plastics. I didn't specialize in metals, but now I work at a company that makes titanium implants for surgical procedures. So a lot of being out on the floor, looking at the parts, looking at the process, measuring things, but also a lot of documentation and customer correspondence and looking into what could be causing those issues and how we might fix them in the future.
Awesome. I'm just going to add to that because I know you guys are both kind of by production, and I was seated at a design and test center. And so there was no lines. They weren't actively building stuff. We would take kind of the manufactured goods, or what people would already, they'd send us parts. So the stuff you guys were working on, we get those parts, we'd build them into like a product that would go in a box and we'd ship. And so our product was the circuit breakers that go in your house, probably in the basement. They've got those switches that you kind of flip if there's a short circuit or something. And so those come in boxes. But what we did was we would actually take the product before we put it in the box, and it would get tested different ways to make sure that, it could withstand enough switches, enough, if there was a big surging current or electricity hit your house, something like that. And so we would test it in the lab. And so the other part was designing it to make it better. And then we would work with people on the manufacturing line. And so I spent maybe about 50% in the lab. And part of that time in the lab was looking at broken, failed product. And that could be from the testing or from a customer or from our what we call audit testing, where you kind of test it to see how it's going to do, or certification testing. And then the other portion in the lab was just watching how do they test it? What do they do? Did they hook it up correct? What wires do they use? So that I could understand if something failed. Was it us? Was it the product? Was it something in the building? So that was about half the time. The other half the time was on the computer. Portion of that was working with the production team. Hey, we have an issue. Hey, you have an issue. If you have an issue, we might see an issue. So could you tell us about that? Maybe we could change something on production so that we fix the product before you ship it to us, before we ship it to customers. The other portion of that 50% on the computer is, answering emails, and that could be from the sales team, from the marketing team. But it could also be, how do we make our product better? So a lot of people have projects going on. And at the design and test center, that's like, how do you make a better product? What are we designing? What are we changing? We could change materials. We could change the shape of the product. And that's where we'd bring in some mechanical engineers, maybe some electrical engineers. Would this cause an issue electrically? But then on the flip side, you guys might have had, a project going on. Hey, we've got a project on the line. So if there's a project on the line that could affect the product, so we might have to verify a change in the line, or maybe you had to use a different machine or a different tool because you were short, and so that's where it looks a bit different. Again, sometimes a lot of companies, you get to kind of go travel to the supplier where they build the parts, or you get to travel to the design and test center to see how they test it. Sometimes we send product to them, and they'll send parts to us, not built yet. And so then we can kind of see what each other's job looks like, but it's all materials engineering, because we're focused on the materials, which is all super exciting. And you've probably heard, this could be in different countries, your product or your parts, you could be shipping it to different customers. And so I think it's really exciting to work with people all over the world. But we're going to transition to a totally different question, but also important. So ladies, could you give some advice on how girls can prepare to be employed in a male-dominated career and how they can successfully communicate and interact with their male colleagues or peers?
Ask questions. Ask lots of questions. Don't feel stupid asking questions. If people talk to you like you're stupid, don't be afraid to say, no, that's not what I meant. I asked this question. Clarify, be specific, demonstrate your knowledge without being overly pushy, but really focus on, I'm here to learn. I'm here to do my best. I bring skills to the table and I want to use them. I want to fine tune them. I want to gain new skills, because really what it comes down to is your team and your colleagues want someone who is fun and easy to work with and who will communicate clearly what you know, what you've learned, what you're seeing, any issues that you've run into. And so the more forthcoming and willing to speak up you are about things that you notice or that you know, the better your reputation will be. And even if you are the one woman in the room, you know, your peers will have no choice but to respect you because you'll know what you're doing. You know, even if it's the, I'm not sure about that yet, but let me look into it and get back to you. Like, that is a response that should become very common in your vocabulary, no matter what field you go into in your career someday, because a willingness to learn, to help, is something that people always appreciate no matter what.
Yeah, I don't know that I have a whole lot to add to that. I really like what you said about asking questions. I ask so many questions all the time. I just started a new job. I've only been there for a month and a half. So most of what I do right now is asking questions. And if they don't have an answer for me right away, I will email them to remind them that I had this question. And if they don't get back to me, I will follow up about once a week until I get an answer. And that way you can show that you're looking for the information that you need so that you can do your job. And if you don't have that information, but you're looking for it, then it shows that you have some tenacity to look for that information that you need. I'm sorry, Kate, what was that last thing you said? I know I had a thought about it.
Just being a team player and demonstrating your desire to share and communicate with others.
I think it was the statement as well. I don't know it, but I'm going to figure it out and I'll get back to you.
Yes, I say that all the time. A lot of people don't have the information that I'm looking for right now, or if they're looking for the information from me, I don't necessarily have it in front of me. So write it down that they asked that question so you don't forget, because if I don't write it down, it doesn't get done. But then once you have that on your to-do list, make sure you get that information and get it back to them. And it's not a big deal if you don't know it right in that moment. You can always go back and find it later.
Yeah, but following up is huge. Like, I know in my mind, the colleagues that I prefer working with that really stick out to me are the people who actually remember to follow up, who actually write things down and do what they say they're going to tell you. There's nothing worse than someone saying, oh yeah, I'll get that to you this afternoon, and then they never do.
Yeah, and I think the two things I had to add were, one, kind of like you mentioned with the clear communication, following up, but also doing it clear, short, right? Everyone's busy. We're going to get lots of emails. So sometimes it happens. We're in a meeting, then we get an email, then we get a message. And I try to just compile all of that in one crisp email. Or if it's a lot of stuff, one meeting with some bullet points. This is what we're going to talk about. But that way it helps both of you or whoever, the group, really just, it's short, it's sweet, it's all together. You can't miss it. And same thing, use the bullet points. If you really need something, put it in bold, right? If it's somehow a lot of info, put all the info maybe at the bottom, but put the question at the top. That way people know the question is for me and they're expecting me to email them back, or this is what I need to do before the meeting. And I think the second one, just to reiterate your great asking questions, you're going to find some people really want to help you and they have all the answers. And those are great people. I'd say lean into them. Like, ask them more questions, right? Especially you'll probably have a mentor or a buddy at first, but you can ask them even some of the basic questions. But if you see someone's really busy, they don't have a lot of time, maybe don't ask them as many questions, right? And so that's where you can kind of find the few important questions that they couldn't answer, that only they could answer. But so again, clear questions are a great kind of bonus to help you get the information quicker and the correct info. And facts, stick to facts. I think that helps us a lot. Sometimes women really like to talk.
Bring data.
And
bring data.
Yes. And
have someone proofread your emails before you send them, especially if you're writing something that is a little bit longer than just a quick note. It never hurts to just drop next door to the person sitting next to you that, has a few minutes and say, hey, can you help me make sure that I worded this as clearly and as briefly as I wanted to, so that it's not overly wordy and it's getting across all the things that I want to make sure I get answers to.
Especially when you're first starting out, or if you don't have a working relationship with the person that you're emailing, it really helps to talk to someone who does have a working relationship with that person to get their feedback on how you've worded your email.
Awesome. So we have one last question, and that is kind of, what advice do you have, or is there something you haven't shared yet that you'd like to, with respect to getting a job, how they can prepare, in high school, college, but what kind of advice do you have for people who are looking to pursue STEM and specifically engineering? Women.
Learn how to code. That's the thing that I wish I had learned much more and much better when I was younger. There was a CAD class that did basic programming, basic like engineering design and CAD drawing work at my high school, and I didn't take it because it was a class full of boys, and I was like, oh, I'm not gonna ever go into that. I don't need to know that. Yes, it would actually be very useful. Would definitely recommend that and just have fun. Like, yes, you're there to learn, to work hard, but when you go through high school and college, like, don't let yourself get overly stressed out by things. Like, yes, meet your deadlines, do good work in group projects, don't be the person in your team that's slowing people up or letting people down, but don't let yourself get so overly stressed by things that you don't ever let yourself have fun or sleep in on a Saturday or something. Like, you're still going to get there. It's going to be fine. So breathe.
Yeah, if you have the opportunity to learn at least the basics of coding and or computer aided design, CAD, even if you're not going to be using those extensively in whatever field you go into, it's still really nice to know the basics. There's so many things in my job that would be a lot easier if I knew the basics of coding and of CAD. I don't need to use it daily, but it would make my life a lot easier. And then also have someone review your resume, and then have someone else review your resume, and then have a bunch of people review your resume. And you don't have to take everything that they suggest because they're going to say contradictory things. Everybody has so many opinions on what you should have on your resume, but have a bunch of people review it and then take what you like from what everyone said and compile that into your resume, and be updating it every time something changes. Because when you're 2 years into a job and you decide that you want to switch to a different job, but now you have to update your resume before you can apply, and your resume is 2 years old. I had that experience. It was a lot of work.
Been there, done that too.
Yep. Keep your resume updated and ask people to review it. There's a lot of people out there who are willing to review it. Your professors, your advisors in school, your some of your friends, get them to review that resume. And then the last thing that I would say is, if you suspect that you need accommodations for something in school, any level of schooling, pursue that. It would have made my life so much easier if I had pursued that a lot sooner. there was a lot of time that I spent struggling in college that I did not need to be struggling that hard. So if you even suspect that there's accommodations out there that could help you, look into that as sooner rather than later, and it will make your life so much better in the long run.
I would advocate the same thing with the coding, the CAD, the accommodations. Just ask for stuff if you're thinking of it. Could this maybe happen or that? Do we offer this? The questions don't hurt, right? Just throw it out there, follow up, and if nothing comes of it, nothing comes of it. But in addition to asking, I'd say take chances. Try something that could be fun, kind of like Kate said, don't hold back from whatever, going to the movies one night or sleeping in. But also, if you get the opportunity and it's like, hey, there's a conference, we're trying to take a freshman, does anyone want to go? I was definitely the one who's like, no, no, I'm gonna miss school. And so I would say take the chance, or like take the chance to learn a second language, take the chance to go somewhere, or to some meeting or something to do an extra design project. Don't overwork yourself, but a lot of those opportunities, you meet people and you just hear ideas. And just that idea was worth the half hour you were at that meeting. And also, like Chelsea said, those are things to put on the resume. If you went to the conference and no one else did, you don't know where that's going to lead. You know, you could be a couple conferences in and now you're the president of something, or you decide to start up your own thing. I'd say don't be afraid of starting. That could be an opportunity. Instead of saying yes, you're saying I'm going to start it. You know, and you can have a group, and that shows a lot. And I'd say with all of that, don't be afraid. If you love something and it's not STEM, or you can't figure out how it's STEM right now, that's okay. But just pursue it. I have friends who pursued music and engineering, and now like they're doing the music of like keys when they're playing it, you know, just like the materials of instruments, but also like the like electronic sound waves. I'm not quite sure, but that I have a friend who pursued art and chemical engineering. She's now studying like ancient paintings and stuff and how that paint changes over time. You know, we've got all these buildings with paint. What happens if they catch on fire and stuff? You can pursue sports and mechanical engineering, right? And you can like design sports equipment. So don't feel like you can't combine 2 or 3 things you love. That's what makes you special, right? A ton of you are going to get an engineering degree, hopefully, or something in STEM. All 3 of us got a materials engineering degree from the same school, but we're doing totally different things. And that's where it's these little things about you that come in that I think are special.
Mm-hmm. We've been hiring new people into my team recently and doing panel interviews. And one of the things that we always ask people is about their interests and what they do for fun outside of work. So make sure you do things for fun outside of school or outside of work. Like, still be a well-rounded person, because those things are important and impact like whether or not you're going to have things in common with your coworkers in the future. You know, that's important too, to be able to, you know, be sitting having lunch with a coworker and talk about the soccer game that was on TV last night, or, you know, whatever is of interest to you. You know, maybe you meet someone that um plays an instrument and you decide to be in a band together. Like, I have coworkers that are in a band together. I have coworkers that play in like league sports together outside of work, you know, all sorts of things. Another thing I was going to add into, based off what Chelsea and Emily were, or not Emily, oh my gosh, Amy, I'm sorry. um, was that if you have an interest or you hear about something that somebody else is working on, whether it's an upperclassman student or one of your teachers or professors, or it's just a random idea you have on your own, go ask someone if they can help you pursue it, or if you can join in that project, or if you can get involved in something, because if you're interested in it and passionate about it on your own, you're going to enjoy it, you're going to accomplish a lot more, and it's going to be something you can put on your resume, and it's going to be way more fun to be interviewing for a job someday and get to immediately like be excited, be happy, be super, super knowledgeable about something when you get asked about this item that you put on your resume, than just having to sit there and be like, oh yeah, I worked at this job while I was a student for 6 months. Yeah, I worked at the coffee shop. Woo. Like, if you can instead, go work in a professor's research lab or be a teacher's aide for a class or something, and like really know a lot of interesting detail, and when the people interviewing you see your excitement, they're going to be a lot more drawn to you. So it's good for you in that you get to enjoy the experience of doing that thing while you're doing it, but then later on it also serves you really well in the future, because you will have your passion as well as the knowledge and skills that you gained from going through that project or that experience. So it kind of serves you in multiple ways.
That's literally how I ended up in materials engineering. Is Kate and I were talking about her research, and I thought it sounded really interesting. And she said, I don't want to bore you with all the chemistry details. And I was like, no, this sounds so cool. Tell me more. And the next semester I switched to materials engineering.
I forgot about that. That's right.
That's how I ended up in materials.
Because we lived in the same dorm freshman year.
Mm-hmm.
Oh my goodness.
Awesome. I'm loving all these stories. Ladies, I want to thank you so much for joining us, and students, I want to thank you so much for listening to us. We hope you've had a blast. We certainly have. So yes, this is what materials engineering looks like, and thank you so much for joining us. We'll see you later.